Hello, this is Sirisha Kisara. My class ID is 14 and my lab partner is Kavin. His class ID is 3. Coming to the first part of the lab 2, implementing linear regression on any data set. I'm taking the weather data history data set. It has temperatures, humidity, wind speed, visibility, etc. So I have implemented linear regression two types. One is like implementing all the necessary libraries here and reading the weather history, and I'm only focusing on taking humidity values and getting the temperature values. So I'm reshaping them, and I've taken a sequential model, uh, added only two dense layers. Initial one will be input dim 1 and the dense of 11 fields, and the activation normal ReLU. For the linear regression, we don't need the activation function for the output, as we are expecting continuous numerical values. And to compile the mean square error, I'm compiling the loss mean square error, and optimizer I'm using Atom optimizer. So here I'm using Keras regressor to perform the regression, in which I'm taking the model that I've already defined, and epochs 2 and batch size 5. Here standardize is used to reduce the mean square error rate. So we are standardizing it, like taking the random states, and finally crosswalk score gives us the mean um, a score of which, by doing the mean of which, we'll get the mean square error and standardized variance. So let me run this code. The other method to do the linear regression is imported the required libraries, and using pandas I've read the weather history CSV, and I've taken the humidity values for the X, and to guess the temperature based on humidity, and I've split the data into test and train, and I've taken learning rate 0.3, epochs 5, batch size 32, and and I've calculated the Atom optimizer using this learning rate and the decay rate that I've taken, and I'm giving the optimizer as Atom and loss as mean squared loss, and here I've given the activations as ReLU, and for the output I'm not giving any activation, and giving the tensor board callbacks to store the to for visualizations purpose and evaluating, and finally printing the mean error and loss. So let me run this code. So as you see, the mean absolute error is 54, is 6, and the loss is 54, and we have got the graph logs here, which we'll use the tensor board to visualize them later. And the second part is the logistic regression. The difference between the linear regression and logistic regression is for linear regression is like predicting the output based on the input. For example, if I'm giving the humidity, what will be the temperature? Coming to the logistic regression, it is the probability based upon the input features determine whether the output is yes or no, chocolate or not, like that. So coming to the code, I have taken the candy data in which I'm going to determine whether the given candy is chocolate or not. I'm eliminating this competitor name field because I don't need it, and I'm taking all other fields into y, and the chocolate values into y, and dropping that and remaining into x data, and normalizing the data, and dividing the data into test and train, and calculating the learning rate, epochs, and batch sizes, decay rate, and using the atom, and giving here I'm giving the sigmoid because here the output is like probability, and I'm giving the loss as binary cross entropy, where in that linear regression I've given mean square loss, and I'm calculating the accuracy finally. So let me run this code, and I'm using a tensor board to visualize that, which will be stored in logs. So as you see, the accuracy is 90.91%, and we have also got the logs here to visualize the loss and a graph in TensorBoard. Thank you.
So this is our last lab assignment, lab 2. So I will be explaining from question number 3 to question number 6. So the question number 3 is to create a text classification with CNN model on spam data text classification. So the question number 3, the first step is to import libraries. The first library is Pandas library, which is mainly used for data manipulation and analysis, sklearn for machine learning, keras for deep learning, and re for some regular expression. So after importing the libraries, we read the dataset. So we have taken the span dataset. So the span dataset and the encoding as Latin 1. So if you see the information about the dataset, it says it has 5,572 entries, that is 5,572 data points, unique data points. And if you see the dataset head, we have a categorical variable called ham or spam, and its message, and others are not necessary. So we'll drop the unnecessary columns using the dot drop off function. And now if you see, we have only these two. So before getting into the CNN model, we need to do some data pre-processing, which can increase our accuracy. The first step is to strip the string, that is to remove the characters in the left side and the right side, and also make all the string to lower cases. For example, if you say a word point which might be differ from the same word point which is in capital, so we'll make all of them to smaller. And now if we count the categories, it says we have 4,825 data points for ham class and 747 for spam class. Again, the first step coming into the deep learning part is, before that we have to make it to tokenization. Tokenization is the process of chopping the string into pieces called tokens. For example, if you put hi Python, this is my last assignment, it will make it hi Python, this is my last assignment, in different as different elements in an array. So for making the tokenization, we have created a model using the tokenizer and fit the text from the message column and made the text to the sequences. And we also applied the path sequences. So in the path sequence, what it does is using path sequences from keras, it changes the 2D numpy array. For example, this would be our first x variable. Next, after applying the pad, it has after applying path sequences, it has become like this. So next one is, now the variables are ham and spam, but we need to make it to categorical variable, which is understandable by the deep learning models. So we have used again the label encoder model, and with the column spam or ham data, spam or ham feature, made it to categorical. So now if you see, it has become 1 or 0. So the first data point would be 1. It's 1 for ham, or at 0 for spam. And the third data point, it's 0 for ham and 1 for spam, like that. So next one is to split the data. We need to split it into train test, that is x train, x test, y train and y test, where x is the features other than the target and y is only the target. So now we would say, now we have got the shapes of all of the train and test variables. Now coming to the CNN model training, the first one is to create a sequential model. Where in sequential model, we can add several layers of embedding, convolutions, max pooling, spatial dropout, etc. And also we have flattened the data set, added the activation layers like ReLU, sigmoid, and etc. Now if you run, you could see the first one is embedding, spatial dropout 1D, convolution 1D, max pooling, convolution 1D 2, max pooling 1D 2, flatten 1, dense. So the total parameters would be some 225,000. Now the next, so now the model is defined. The second part of the deep learning to fit the model with some hyperparameters like epochs, batch size, and the burst. Epoch is 16, that is running for 16 times, and batch size is undertaking 100 data points for each step. So here if you look, we have trained for 16 epochs, and to find the accuracy we have used the model.evaluate the accuracy. So we have got 98% accurate, of score 17.93. Now going to the question number 4. In question number 4, instead of applying CNN, we need to apply LSTM. So coming to the LSTM part, we'll repeat the same steps until the model training. So using LSTM, we have got about accuracy of 69%, which is much reduced than CNN. So we could say that CNN has given a better accuracy than LSTM. Next, coming to question number 6. In question number 6, we have to use the different data set which we have never used before. So, and to use the image classification, here we have used Cipher 100. The first one is, as usual, import the libraries. We have mainly imported two libraries, NumPy to perform on which uses to perform operations on larger multidimensional arrays, and Keras for doing operations on deep learning. We are using NumPy because most of the image datasets are in the form of arrays, and specifically multidimensional arrays. So if we have loaded the Cipher 100 into X train, Y train, X test, and Y test like before, and normalize the dataset and change it into categorical variable. We have 100 classes, and the first step is to create the sequential, and the next adding the layers for the CNN, as similar to ICP4. You can refer to ICP4 what are these layers referred to. And at last we have added an optimizer called Adamax. So all these layers with the Adamax optimizer are trained on 50,000 samples and validated on 10,000 samples for only one epoch, which took us like 712 seconds. We have made it into the larger epochs. For the better accuracy, we have got accuracy of 0.1, that is 0.009. This is 1% of nearly 1% of accuracy for one epoch. If you go for greater epochs, we would get a better results. We are doing that, and we will be updating in the wiki page. And this is our lab 2 question number 6. Thank you.